let's look at situations where work can occur and think about what happens with work here. If there's a lot of forces on an object, okay, which of them can actually do work? And the answer is that all the forces acting on the object do work if you can resolve the force so that there is a component that is acting in the same plane as the displacement of the object. This topic, I was taught this as work is force times distance moved in the direction of the force. So basically, if you can get a force in the direction of the movement, then you're fine. So all forces do work if the force can be resolved into a component that is in the same plane as the displacement. Okay? Now, we're going to end up with work with a positive value and work with a negative value. It is not a direction, it's an increase or decrease in energy of the system. Okay? So if the force or its component and the displacement are in the same direction, the work done by the force has a positive value. So this positive value means energy is being transferred to the system and the total mechanical energy of the system increases. Remember mechanical energy from grade 10? It's a combination of your potential and kinetic energy. Okay? So the moment the force and its displacement are moving in the same direction, the work has a positive value, the energy of the system increases. If you have a force acting on the object, and the force or its component is in an opposite direction to the displacement, the way the object is moving, then the work done by the force has a negative value. This is usually friction, okay? Friction opposes motion, so friction is always in the opposite direction to motion. And what happens is this force has a negative, the work done by this force has a negative value because it is taking energy out of the system and the mechanical energy of the system decreases. Okay? Then there's one situation to consider. In grade 10, when we looked at mechanical energy, we looked at mechanical energy as the combination of potential energy and kinetic energy. Okay? And we only looked at closed systems. Here we sometimes have something that's not a closed system. So that means energy is going to be lost. Okay? So if the forces are acting on a system and is not a closed system, it means the mechanical energy is not constant, it is changing. This is nearly always energy is being lost due to friction or something like that. So in a closed system, there's no friction, but if we get a system where there's friction, mechanical energy is going to change. You can work out how much work is done by each individual force. Okay, so in that one example, there's two forces on the object. So you can work out each of those individual forces separately. And the algebraic sum, remember one is positive, one is negative. This is why we say the algebraic sum. So the algebraic sum of the work done by each individual force will be equal to the net work done on the system. So this is looking at the net work in terms of the work done by each force. Okay, so I don't like doing this. I like doing this. The net work done on the system can also be calculated by using the net force instead of the applied forces. So you look at the question, you pretend it's a Newton's law question, but you know it's not. And then you calculate all the forces, you resolve all the forces till you've got them all where they can be added or subtracted because they're in a straight line. You calculate the net force and then you multiply it by how far the object moved, and boom, you found your net work. Okay, so the net work done on the system can be calculated using the net force instead of the applied forces. Okay, so here you find individual works, here you find one force. You're going to end up with the same answer if you do this either way. So this net work is equal to the change in the kinetic energy of the object, because the net work is what's making the object move, and it's equal to the change in the kinetic energy. Remember, kinetic energy, a half mv squared. So then we need to have a look at more things that have to do with this. So for instance, a negative value for work means the energy of the system has decreased. It doesn't mean direction. Energy is a scalar, not a vector. Okay, so look here, situations that affect the sign of work. So remember these pictures, they relate to this. If you push a box and the force is in the same direction as the box is moving, we've done positive work. If you push a box and there's friction opposing the motion, the friction is doing negative work. If there's a force at 90 degrees to the motion, there's no work. And if the object is not moving, there's no work, because the definition of work needs displacement. Remember, jogging on the spot, you're not working. So look at practical examples. If you push the wall, okay, so you make a force on the wall and the wall is not moving, you are doing no work on the wall. That's just the way it is. Your muscles might tell you something else, but physics says no work is being done on the wall. If you pick up a bag and you put it on your back and you walk around for an hour at a constant velocity and a constant height, you have done no work on the bag, because the force you applied to the bag to lift it up is perpendicular to the direction of the motion. So anything that's at right angles to the direction of the motion, there is no work done by that force. So no work has been done on the bag for the whole hour that you wandered around with it. Physics, it's marvelous. So if you look at this example, a car is moving eastward. If it brakes, the braking force is in the direction opposite to motion. Remember, the braking is a form of friction. It's going to slow you down. So if you look at the braking force by itself, the work done is F delta X, and the angle is 180. So the cos of 180 is -1. So it becomes, the work done is the negative value. So this negative value means energy is decreasing. So you have to think of the energy and the forces slightly differently, okay? So the work is still done, but it's done and it removes energy from the system. So the total mechanical energy of the system decreases because the kinetic energy decreases. So you can see those kinetic energy and potential energy equations are very related to work, energy, and power. Okay, so here's this picture again. Only if the force is in the direction of motion is there work done. Okay, let's stop here again.